Okay. Now I think I can start my class. Okay. So last class we have done some exact equations. We have solved some exact equations and we have found out some integrating factors. Multiplying by these integrating factors, the differential equation can be made exact. And we have used only two rules and there are two more rules. Okay. So the rule number 3 is another. There will be similar kind of two rules. That is, one is if your y by m del m 1 by n 1 by m, this is del n del x minus del m del y is equal to function of y only if you have a equation in the form mdx plus ndy is equal to 0 and this equation is not exact, then this 1 by m del n del x minus del m del y if is a function of y only, then it will, the integrating factor will be uh, this integration. So how we can apply it? We can apply it, suppose xy dx plus 2x square plus 3y square minus 20 dy is equal to 0. Now here your m is xy, so your del m del y is nothing but x and your del n del x is 4x. So your del m del y not is equal to del n del x. So this equation is not exact. So what, now you can see this del m del y is a function of x and this uh, uh, del n del x is function of x. Now one, your m is x by y, xy. So this is 1 by m del n del x del n del y. It will be del n del x is 4x minus, that will be 3x by xy. So this is a function of y only, you don't have any x. So your integrating factor will be e to the power sorry, this will be function of y. If this is a function of, say I may say this is phi y, so your integrating factor will be phi y dy. So in this case, our integrating factor is e to the power 3 by y dy. So you will integrate and the result will be log, that means y cube, right? So this is, okay, this is the rule. If you have this, this satisfies your, that is your, this subtraction is a function of y only, then you can apply the rule, that is your integrating factor is this. So if this is my integrating factor, I will multiply this equation by this integrating factor. So my main equation will be That is, multiplying this by y cube, I will have xy to the power dx plus 2x square y cube plus 3y to the power 5 minus 20 y cube dy is equal to 0. And now you can see I can write this as half of d x square y4. That is, this will be x square, 4, that's 2 will be cancelled, and this will be, and this is, you can easily integrate. So integrating, we will have x square y4 half plus 3 6 y6 minus 20 y4 by 4 is equal to, that will be c. And we can cancel out this half, and I will have, so you can simplify and you got the solution, right? So this is another rule of finding an integrating factor. Okay, and there is a similar kind of rule, that is, it was rule number 3. So rule number 4 will be, one is 1 by m and one is 1 by n, and the, and if you this, if you may change the order, there will be only a minus sign, so that is not the point. So if it was function of y, then our integrating factor was e to the power fy dy integration. So if it is a function of x only, then you will have a integrating factor in this form. So I am giving you an example so that this is okay. So this is example of x dy dx minus 4y is equal to x to the power 6 ex. Okay. 4y. Okay. So I may write this in the form of m dx n dy. So this will be nothing but x dy minus 4y dx minus, okay, so you know your m is x to the power 6 e, this is minus of this, your m is minus 4y. Okay, so your del m del y is minus 4 and your n is x. So del n del x is equal to 1. Okay. So this is del m del y not is equal to del n del x. So this equation is not exact. So now what is 1 by n del m del y minus del n del x is 1 by n is x, and what is your del m del y is minus 4, and this is minus 1. So this is minus 5. So this is your integrating factor is minus e to the power if will be e to the power minus 5 by x dx. So you can easily integrate this, and you know the integration will be minus, so this will be 1 by x to the power 5, right? Okay, now multiply this with the given equation and solve me and tell me what is the result. I am sorry, since I don't have any space, I have written down this IF here. This your IF is 1 by x to the power 5. So you will multiply this integrating factor with the given equation. So multiply this and tell me the solution.
Ma'am, the answer will be y equals to x to the power 4 e to the power x into x minus 1 plus c into x to the power 4.
Uh, okay,
Yes, ma'am, it is.
okay, fine. Now, in the first PDF, what I have given to you, there are many examples, there are exercises given, okay? So you will be able to solve using these formulas, that is either making it exact or by separation of variables or, okay, and only first chapter I have to do for some linear equations of first order and some Bernoulli's equation, okay? So then our first chapter will be finished. And there is an exercise given, so you have to solve those problems. And if you have some another book which have some problems on this chapter, so you may solve those problems also. That will be your for practice only. So now you have done Bernoulli's equation in your plus 2, but I hope you don't have this form before, or you know the forms. Linear equation first order. I am writing this as dy dx plus py is equal to q, where p and q both are either constants or functions of x only. Since it is linear, no multiplication between there will be no product of y dy dx or something like that, okay? It is a linear first order differential equation. It is the general form where P and Q will be either constants or functions of x only. Now, suppose we have to solve, we don't know whether this is exact or not. Suppose I multiply this equation by R. That is, R is an integrating factor. So R di dx, so that it is exact. So RPy is equal to RQ. So if we multiply, this is an integrating factor, so it is a functions of x. So if I multiply this by this equation, so it will be an exact equation, so that your left hand side and right hand side I may write. Now if you know this R dy dx term only can come from this, right? So your ddx of ry is nothing but r dy dx plus y dr dx. So I may say this is r dy dx is this, and this is rpy is equal to y dr dx. So I may equate this rp is dr dx. So you know it will be p dx is equal to dr by r. Now you can easily integrate, and you got your log r is equal to, and that is your r is equal to, and how you have already got this is an integrating factor. Okay, so now sometimes if you know this is a linear first order equation, you can always find out your r. And suppose sometimes it happens it is in the form and suppose it is in the form dy dx plus py is equal to qy to the power n. And probably you have known this equation as have you solved this type of problems before? Hello? Have you solved this type of problems before, this Bernoulli's
Yes,
equation?
yes, yes, ma'am.
Okay. Since our form, that is your q, this right side will be functions of x only. We know these p and q are functions of x only, so you will remove this yn, that is I will divide by this, and this will be y to the power minus n dy dx plus py 1 minus n, this will be q. And I will substitute this y minus n is equal to v. So your this will be 1 minus n y to the power minus n dy dx will be your dv dx. I have differentiated properly, right? 1 minus n, this will be minus 1, y minus 1 dy dx is equal to dv dx, right? So this will be written as dv dx, and if by y minus n, if I multiply it by y minus n, so this will be 1 minus n pv, this will be 1 minus n into q, right? So this is in the form dy dx plus py is equal to q, this in form of linear equation. Okay, so this is free from y, and this p is here given by 1 minus 1 into p. This is y is v here, and your q is 1 minus 1 into q. So your integrating factor will be nothing but, what will be your integrating factor? E to the power 1 minus n p dx. Basically, this is, since this is constant, this will be outside of the integration, doesn't matter whether it is in free of x. So this is your integrating factor, and so we will transform these kind of equations in the form of this, so that we can easily solve this type of problems as before. And suppose it is of the form dx dy plus p1x is equal to q1. So it will be solved as before. Here your x is the dependent variable and y is the independent variable. Okay, so your p1 and q1 will be functions of y. This is same, just your dependent and independent variable is changed. So you can easily solve this type of problems like this: dy dx plus py is equal to q. So now I will give some examples so that you can. Have you solved this type of problems before? I am not sure. Okay. So suppose my first problem will be, my first problem. Oh. Now here your p is minus 3 by x plus 2. Here your q is x plus 2 whole cube. Right? This is in the form dy dx plus py is equal to q. So your integrating factor will be e to the power, right? Now it will be log x plus 2 minus, so that will be this, right? So your integrating factor is this. So I will multiply this equation by this integrating factor, multiplying by if. What we get, and after multiplying this equation, what is your, the left side of a linear equation will be always y into if. So what is your y into this left side will be y into if is x plus, what I mean to say, your left side will be always this ddx of this, and your right side I have to multiply. And okay, I haven't, now I have to integrate this. So this will be nothing but dx. mm, uh, okay, I should not hear this ddx of this, I should write this here 1. So if I am integrating, then I will get the result. or if I say dx. Okay. So have you understood the process? What we are doing with the linear equations? Okay, I am giving you an example. No, I am giving you a problem and you solve it. Okay. So suppose solve 4x square y minus 6 dx plus x cube dy is equal to 0. Okay, solve. That is, you first write in the form of this linear equation and solve and then tell me. And what I am trying to say right now, I am telling you is solving in this process, but otherwise you are free to solve any differential equation in any rule you know.
Ma'am, y x to the power 4 equals to 3x square plus c.
Y equal to
Y x
3.
to the
Yes,
power
yes, it is.
4 is equal to 3x
3x
square plus
X
c.
square plus C.
Right, right. Okay, now then solve 1 plus y square dx minus tan inverse y minus x dy is equal to 0.
Oh. The answer will be x e to the power minus tan inverse y equals to minus e to the power minus tan inverse y into tan inverse y plus 1 plus c.
Ma'am, hello.
Hmm?
Ma'am, I have got something different. Ma'am, the
Okay,
answer
tan
will be
inverse y
e
plus
to the power
1.
tan inverse y into x equals to e to the power tan inverse y plus c.
Ma'am, that will be e to the power minus tan inverse y.
Uh, no, that will be to the power tan inverse
Oh,
y.
oh, ma'am,
No,
sorry,
minus
sorry.
होगा.
Because
I have
your
made a
IF will be
mistake.
1 by 1 plus y square dx. So you
Yes,
will
Yes,
ma'am,
ma'am.
I
write
have
e to
made
the
a
power tan
Yes, ma'am.
inverse
Yes, ma'am.
y. So it will be your plus e to the power tan inverse y, tan inverse y. This will be minus 1 here, not plus 1.
एक constant.
And there will be another constant.
On.
So, and there will be a constant. Okay. So now I am giving you another problem that is in Bernoulli's form. Okay. So this will be x dy dx. This is a very simple plus y is equal to x square y square.
Ma'am, this can be to that d of y d of yx by x square y square.
Yes, tell
Equal.
me.
It will be d of yx by x square y square equals to 1 means d of theta by theta square equals to 1.
Uh, of this x dy dx plus y is equal to x square y square for this problem.
X
This
dy
will
plus y dx, it will be d of yx equals to x square y square dx. Then x square y square will, to denominator and it will be in exact equation.
okay. This solution. Okay, you can solve. This will be right 1 by xy is equal to minus x plus c. Right.
Yes, yes, yes.
Okay. So I am giving you another example so that so y by x log y is equal to this is y by x square log y square.
Ma'am, the log y in the LHS is in the denominator,
No,
right?
no, no. This is
It is multiplied with y.
multiplied with y. That is dy dx plus y by x. Okay.
Okay.
So first you have to remove this y log y and then transform and solve. The answer is
Ma'am, the answer will be 1 by x log y equals to 1 by 2x square plus c.
okay. It is the answer is given in the answer section, so you just
Yes,
check.
we can rearrange it and it will come to this form.
Okay, sure, no problem. So you will be able to solve now first order, first degree differential equations till now. Okay, so you have your examples in the given in the exercise, or you will solve, and there will be some different problems also maybe there, and you will be able to solve those kind of problems. Now I am going to the next chapter, that is linear differential equation, linear differential equations with constant coefficients. Okay. First, linear differential equations with constant coefficients. Okay, these we have already solved only the first order linear differential equation, right? Now we will solve higher order linear differential equation. One chapter will be with constant coefficients, and there will be some problems Cauchy-Euler equations which we can transform to linear differential equations with constant coefficients. So general form will be nth order linear differentiation will be okay. This is a nth order ordinary linear differential equation. You know, for linear differential equation there will be no product term of y and the derivatives of the dependent and independent variable. There will be no terms like that. So you are there these p1, pn and x can be constants or functions of x only. You have already solved these types of problem. Their p and q were functions and functions of x or constants only, and here our p1 pn all the coefficients either functions of x or a constants only. And for this chapter we will consider these terms only constants. That means our p1 p2 pn is not functions of x, but our x is can be a function of x, no problem. And there are, you know, this type of equation, if this x is 0, this is called a homogeneous equation. And if your right side is not 0, and I think you have solved the second order linear differential homogeneous equation. That is, in class 2 you have solved the second order with the right side 0, that is homogeneous equation. And we have to find out the solution of nth order, general nth order linear differential equation with constant coefficients. There are some rules. Now there are some statements which we will use, that the theorem of the statement of the theorem, but we won't do the proof. And if you wish to know the proof, in the pdf I have given, the proofs are also there. Okay, but we have to use we will use the statement only for our problems, so I am not going through the proofs. But if you wish to know how these formulas came or something like the derivation, you can go through the pdf. Okay, suppose y Obviously, your all it is a only one independent variable, so your any kind of solution will be in terms of x only. So suppose your y is equal to fx is a general solution of the homogeneous equation. Homogeneous equation means I am mean this equation where my right side is 0. Suppose this y is equal to fx is a solution of this homogeneous equation, and y is equal to phi x be an any solution of this particular, that is right side is x given solution, then y is equal to fx plus phi x will be the general solution of the equation 2. I mean this equation. You will be given this equation, right, where the right side is not 0. First, we will find out a general solution y is equal to fx of the homogeneous equation. That is, we will take the only the left hand side, we will write the 0 on the right hand side, we will find a general solution, and there are some rules how to find out the general solution of this homogeneous equation. Then we will find out this fx. Then we will try to find out the particular solutions of this equation which will satisfy this equation, and this is denoted by phi x. Then your general complete solution will be, the first part will be general solution of the homogeneous equation. This is complementary function, or short form CF, and this is particular integral, because I am checking this for a particular value, so I will get a particular solution here. So a particular integral, it is called as pi. So our general complete solution y will be sum of the complete function, a complementary function, and the particular integral. So if we have to solve this type of linear differential equation, non-homogeneous, first we will find out the solution homogeneous, and then we will find a particular integral, then we will sum these two and we will get the general solution of this equation. Now, first we have to suppose you remember one thing. You remember your y1 was sine x is a solution of this equation, and y2 cos x was solution of this equation. So our general solution was, right? So I have to find out, this is an homogeneous equation. So I have this sine x cos x is one, that is only sine x is also a solution, only cos x is also the solution, and this will be, basically this is our complementary function. And okay, now how to find out this complementary function of a homogeneous equation? So before that we will know some notations, right? Okay, I should. Okay, we will use a notation which will be denoted by this capital D. So this is an operator, that means dy will denote, okay, d2 y will be this. So this operator, this is difference. I have written this as a, so this is dn plus p1 dn minus 1. I can write this equation dny like this. I know this dny will be dny dx to the power n, right? So I have written this operator in terms of d, and this I may write, this is fd. This is uh, the whole thing I may write is fd y is equal to x. Now, before we proceed, we have to one thing is, suppose d minus m1y. This is nothing but dy dx minus m1y. Now, suppose I have, that means your d minus m2 will be operated on y first, then this d minus m1 will be operated on y. This is nothing but d minus m1 dy dx minus m2y, and this d is d2y dx minus m1 dy dx minus m2 dy dx plus m1 m2y. Now if we write d minus m2 d minus m1y, we will come to the same. That means whether we are operate this first or this first, the order of the occurrence won't matter in the result. So suppose when we will factorize, that doesn't matter whether we write first or this is right first. Your d minus m1, okay, and there will be another thing that is independent of the order in which way you operate the difference operator on y, that will be of same result. So another will be, so next term will be, okay, next is, suppose this is written as f dy is equal to x. Now the homogeneous part of this equation will be, your right side is 0. Now if we find the roots of these fd, that is your sum m, That is, okay, that is if I, so we have to factorize this nth order in n factors. So d minus m1, d minus m2, and we have already checked that in any order you may write this, the resultant will be the same. So then we will get a solution from this. We will get a solution from this, and we will get a solution from this, and the complementary, suppose, so this is a linear differential equation. So the solution you already, you can, if you integrate, you will get this. From this you will get C2 M2x. From this you will get Cn. So the general solution of this homogeneous equation will be nothing but C1 e to the power m1x plus C2 e to the power m2x Cn e to the power mnx. You remember in class 2 you have taken the auxiliary solution of e to the power mx, and you have taken that e to the power mx not is equal to 0. And why you would have taken this e to the power mx as auxiliary equation? Because you have got this from this integrating this linear differential equation of first order, and that's why you have taken your auxiliary equation in terms of e to the power m1x. And I know you have already solved this type of problems in order 2, probably, right? You have done this, right? You haven't solved any kind of differential equation? You can follow the process. So, okay. Suppose you have a equation of so you have to find out the solution of these equations. So what you will get, this is 2mq. This auxiliary equation is 2 is equal to 0. And what will be your factorization? Your factorization will be is equal to, okay, tell me, factorize and tell me what will be the value of m. What is the value of m?
Um, 1, 2 and a half.
1, 2.5. So our general solution, that is our complementary function of this problem, will be, I will put m1 is equal to 1, that is y is equal to c1 e to the power x plus c2 e to the power 2x plus c3 e to the power half x, right? And since it is a third order and you have arbitrary constants only 3, c1, c2, c3, so this is your general solution of this differential equation, and it is an homogeneous equation. You don't have any right side part. So first we will find out the, this is our CF, this is CF of the given equation. And since this equation doesn't have any x, so we don't have to find out the particular integral here. And now there are another two rules of this finding, because these roots are not repeated, right? Suppose there is m112. So for repeated roots, and how do we get this repeated root solution? I can use the formula directly, or we can also derive how it comes. Okay, so if you have a repeated root m, so you must have some this type of factor, right? Your m will be comes twice in your factorization. So this is, suppose I am taking d minus my, I am writing this as u. This is nothing but d minus m, d minus my is equal to 0. I am writing another substitution here. So this is a linear differential equation du. So you have got u is equal to c2 e to the power mx, and now I will solve this d minus my is equal to c2 e to the power mx. Can you solve it? Can you try it? This is a linear differential equation. Can you try it? Try and tell me what you got. IF is e to the power integration of minus mx. So your IF is, you have solved, and what you have got? So if you have a repeated root twice, then you will have a term like c1 plus c2x in your complementary function e to the power mx. If you have repeated root for 3 times, this term will be c1 plus c2x plus c3x square multiplied by e to the power mx. Okay, so this will be your solution of this equation. So your complementary function will come with these terms. Now I have given you an example. So I hope you have understood how this came. Suppose another example will be like x d4y dx4 minus d cube y dx cube minus 9 d2y dx square minus 11 dy dx minus 4y. Tell me what will be the roots of this auxiliary equation. These can be written as that means auxiliary equation is m4 minus m cube minus 9m square minus 11m. What is your aim here?
One root is minus 1 with multiplicity.
Minus 1. Yes, tell me. I couldn't hear you. Tell me. And this is a problem of repeated roots.
And
Have you
then
got
4,
this?
4. Minus
This
1
is
minus
4,
4.
right? So
Yes, ma'am.
your CF will be C1 plus C2x plus C3x square into e to the power minus x plus C4 e to the power 4x. Because this 4 is here and another is e to the power minus x, and since it is repeated, this term will come. And there are another term, that is term, I won't tell you the term. Suppose you have roots, complex roots of the equation, right? Complex roots occur in conjugates. So suppose you have your roots like, say, alpha plus I beta, alpha minus I beta. So this is your imaginary part, and you know you have your solution was C1 e to the power alpha plus I beta x plus C2 e to the power alpha minus I beta x. Now you can simplify this. That is for both the terms. You can e to the power alpha x. So you have C1 e to the power uh, I beta x plus C2 e to the power minus I beta x. And if you know the e to the power ix is nothing but cos x plus I sin x. So e to the power minus ix nothing but cos x minus I sin x. So there will be, if we simplify further, it will be e to the power alpha x. This will be C1 plus C2 cos beta x plus C1 minus IC2. No, there will be I, another I here. I multiplied IC1 minus IC2 with sine beta x. And I will write this term as A and write this term is B. So your form will be okay. I'm just taking my word file, otherwise. So this will be your y is equal to e to the power alpha x a cos beta x plus b sin beta x. So suppose you have a problem like d2y dx square minus 4 dy dx plus 13x is equal to 0. So your auxiliary equation will be m square minus 4m plus 13 is equal to 0. M is equal to 4 plus minus 4 into 13 by 2. So this will be 2 plus minus 16 minus uh, that will be that will be 36. Uh, 36 means 6 will be okay. So this will be 3i. Okay, so this your y will be e to the power alpha x means e to the power 2x a cos 3x plus b sin 3x. Okay, they are these order of this differential equation may be greater than 2. That means there may be say a pair of complex roots, some real roots. So you will have the solution with these a cos terms plus some e to the power terms which are real, not complex roots of the auxiliary equation. So whatever be the problem, you will be able to solve. Now any type of equation, homogeneous equation, you will be able to find the complementary function for any type of coefficients. Okay, so now you know how to get your CF. Next part we will do how to find my PI. So that will be done in my next class. Okay, and I have sent you the PDF about this chapter also. So up to this you may go through the, maybe you go through the proofs of the theorem, statement of the theorems. Okay, you may. And there are examples in the given, that is finding the complementary function. There is an exercise given, so solve those exercises too, so that our next class will be on finding the particular integral. And I will only use the rules and we will mention the rules, and we have to solve the equation using those rules, and you don't need to know the proof of the statements. Okay, you just have to use the rule. So any questions there?